Uh, Good morning. It is day 13, I think, um, of coding every day until I get a job, which I haven't applied to any jobs in the last couple weeks. Um, but I will as soon as I'm done. Just this final today. So yeah, it's exam day for Discrete Math. Um, I already started recording this, and I was actually like going to do like just 3 hours of Discrete Math, and I'm like, that's not coding every day. So I'm going to attempt the advent of code before 11:30. So my quickest advent of code ever. Um, I'm just gonna see what we can get done. Um, Wherever I'm at 11:30, hands up, I'm done. And then I need to go study. So there's gonna be a quick. There's gonna be like an under an hour. Maybe I'll do a little discrete math and just hit the hour mark. So yeah, we'll see. So Notepad. Um, I'm gonna code day 11. Is this the LRU caching? Um, brute forced part one. Part two was to deter that LRU cache. Fixed it. Um, okay. Keep work 13. Um, do as much admin of code in 40 min. Um, Review old midterms and finals. So I'll do the review here. My plan was to review these midterms that we've already had this semester. Just like look at the solutions. I'm not going to go through them. Um, and then I'm going to review the first final, like strictly just read through it, see the formatting, see all that. And on the second one, I'm going to go through. Um, I'm just going to go through it and like without the solutions, and like if I get really stuck and I don't know instantly, I'm just gonna go and like look up the solution, and just see what questions I have as I'm going through it. Third one is going to be very little assistance. I'm going to give myself time to really try it, and then I'll go through assistance. And the last one, I'll just fully complete without any assistance, and then see how I did and what really is blaring. Hopefully, I can finish all of that before I leave around 1. Probably can't, but I'll get to the school at like 2. The exam is not until 7 p.m., so I can definitely just do that last one at the school. Um, and then whatever was like, like I said, was like kind of obvious that I'm struggling with, I'll put review into that and then practice like another old final, and then hopefully that's good enough. So anyways, I don't have a lot of time for admin of code, so we're gonna do admin of code. Neovim. Hmm. CD downloads. CD admin of code. CD day 12. Um, and I think I need a echo, yeah, greater than echo data dot txt, then echo day twe day twe dot py. Um, so now I can go to data dot txt for day 12. I'm guessing this is going to be a larger example. Okay, I'll just open a new neovim for both of these. Day twe dot py and advent of code day number 12. Def part 1, def part 2, part 1. Okay. Why not search for the chief historian near the gardener in his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if they can lend you a hand. They like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it'll cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant, they form a region. So A is a region, B is a region, C is a region, D is a region, E is a region. Okay, this program includes garden plots growing 5 different types of plants, A, B, C, D, E, and each grouped in their own region. In order to accurately calculate the cost of the fence around a single region, you need to know the region's area and perimeter. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, and C plants are each in a region of area 4. The E-type plants are in a region 3. And D plants, yeah. Each garden plot is a square. Garden plot is a square and has 4 sides. Okay, the perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. Type A and C plants are each in a region with a perimeter of 10. Wait, what? Each garden plot is a square and has 4 sides. The perimeter of the region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. Type B and E with 8. Visually indicating. Okay, that's what I was thinking. That it's like this is 1, 2, 3, 4. So like all these lines are the perimeter. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. For example, there's 5 regions, one containing all of the 0 garden plots and the other 4 containing a single X plot. The 4 X regions have an area of 1 with a perimeter of 4. The region containing 21 types O is more complicated. In addition to its, yeah, didn't it say everything's a square? This is not, like these are, okay. In addition to its outer edge contributing a perimeter of 20, its boundary to the condition is show 4 for a total perimeter of 36. Due to modern business practices, the price of the fence required for the region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on the map is found by adding together the price of fence regions. So the first example, A has a price of 4 times 10. Okay, yeah. So we have to find. Why did this ever say? Did this not say each garden plot is a square and has 4 sides? It's, this does not look like a fucking square. I'm sorry. There's 1, 2, 3, 4, 5, 6, 7, 8 sides to this. But okay. I'm just trying to think if there's a consistent pattern between. Huh. How could one do this? So like for this, right? It's like if you just added up all the R's, which is 8, 9, 10, 11, 12, right? It's 12 R's. So that's its area, right? Yeah, it's 12 of these. So to get the areas, all we have to do is just go through it once and then we get all the areas. But at the same time, I think to find the perimeter, if you just look at each digit and you look around it and you just say like, um, is this like for instance, in this example, right? If I were to, so on the outside it says that it's a perimeter of 36, or no, of 20. Yeah, 20, and then additional this. So if you looked at this, right, and you said there's there, so one, two, because this isn't that. So you have this has a value of two perimeter edges. This has a value of two perimeter edges, right? And I think if you go around, this will add up to 36. So I think all you have to do is just for each one, you just have to increase that dictionary frequency by whatever, right? And then also you need to store. So I think I'm going to store two things. I'm going to store for each type, I'm going to store a like a perimeter count and an area count, right? So like if I mean, okay, so first I need a with open data.txt. We want to read this as a file. Um, for how do I want to read this in? I want to simply just a 2D array, right? For line in file, um, line, uh, new array equals this. I need to define an empty one, which will just be our, what was it called? Our garden. For char in line, or for, I'll say block in line. New array dot append block. Sorry if you can hear my dog. And just outside this, I just do new array. Oh no. Garden dot append new array. And then just print our garden. Make sure that looks fine. I do this every fucking time, dot strip. Okay, beautiful. Uh, Up next, I want to take each one of these and I want to, let's just call it the garden map. Fuck it. I think this is correct what I'm trying to get at here, but like just for each one, um, Python making, whoa, not what I wanted. Python making uh value an array. I can just append it as, I know you can do it. I mean, okay, what is it? I would want it to be, so I want to go through the whole thing. Go down to this example, and I want to say like for line in garden or block in line, I want to say like, okay, if fuck, what is it? It's like if the block is in the garden map, right? If it's already in there, the key is, then I want to if block is not in the garden map, I want to initialize it. So I want garden map at block to equal 1. What, just like 0, 0? I mean, if it's there, it's going to be a 1, 0 because we want to start the frequency there. Um, if it is in there, right? Else, if it is in there, we just want to say that garden map at that block equals this is a little more complex. It's like the whole like how do I increment um how do I increment the map value array, both values, one by one, other by 4. Oh, smart. So it's at this and then at that value, at that first value and at that second value. Very smart. Plus equals 1, and then plus equals 4. This has to change, but I'm just saying like for now. So we have it. So if it's not already in our garden map, we just initialize it to that. But that's not what I want. I don't want to just initialize it and then move on, right? Because I need to find out at that one what its perimeter is. So I have to check. So I need to initialize directions. Directions is equal to fuck. I won't lie. I need to go to day 10.py. Nope. Day 9, day 11. Really? Day 8? Where was it where I had the directions? What? There's Yesterday was LRU cache. No shot, it was day 7. What? Okay, this thing is just elusive. I have enough code. Bro, I swear I have it somewhere here. Okay, I guess not. Um, I guess I'll do my brute force way that but no, I don't have a lot of time. Um, if before initializing, whoa. If before initializing I wanted to check in the 2D array if the block has the same value on all four sides. This was what I wanted. This was what I wanted. Okay, so it was that. I didn't know the syntax. I didn't know if this was another, so this is just an array. Okay, yeah. Traverse the garden. Whoa, whoa, whoa. Okay. I'll do it your way. For a line in the range of garden. In the range of rows. Garden at 0, motherfucker. And then the range of columns. Would that now be the length of garden? This should be the length of garden at this. Um, and so I want to say that our current block is equal to our garden at I at J. Yeah. And then for direction column in directions. Is equal to I plus drj plus dc. So this is doing, okay, so for dr, dc, and directions. Print dr So that's just looping through everything. A lot of negatives in that bitch. Probably don't want that. That's why we do an if 0 less than or equal to ni. So he does rows. Like, why are you doing rows? he just defines that beforehand. That actually is a smart. It should probably be there. So this is just replacing this with calls. Wait, why would columns be the length of the first one and rows be the length of just garden? Shouldn't this be the other way around? Am I tripping? Oh my God, no. I am literally just the fucking stupidest motherfucker on this earth. Actually. Okay. Our current block. This. Then a bounds check that if less than rows and zero. So that's our bounds check. And we want to say but instead of this, right? Instead of what this is saying, what I want to do is I want to say, okay, I still don't get like I don't have time for this. I can't wait until I can actually like sit here for like 3 hours and go through this. This last like 2 weeks have just been such painful weeks of school. Do you really have to? You don't have to do this, right? I mean, I guess this is just like good technique. So we go through and we say current block is equal to this, and then in our garden map, current block. But this is assuming that it exists, right? Wait, at current log. Oh, you don't need to check for the key before updating. Doing doing a default dictionary automatically initializes every key. Wow. Whoa, that's fun. Yeah, I mean this is exactly what I'm looking for. I'm pretty sure. Right. 12 and 18 works, but I being this is crazy. Wait, what are you talking about? This is only 8. There's an I here, an I here, 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 here. Oh, oh. Wait, is this gonna be the same thing? Because I got, what, 18 different sides? 4, 14. Wait, I need to pull up a calculator for this. Please tell me it's the same. So this is gonna be 18 times 30, 540. That doesn't look. Oh, wait. Oh, yeah. That's 308 and that's 32. Fuck, bro. So it has to be by region. Fuck. Well, if you think about it, right? Every point's going to have a coordinate, right? All the ones that are next to each other are going to have some link by one, right? So you could say if there is ever a difference, I don't know how you do that. I actually don't know how you do that. How do you connected components analysis? A common technique in graph theory, often implemented in depth first search. So read and represent the load the garden. Okay, traverse garden for each block. Perform a DFS to explore all connected blocks. Oh my god. Calculate cluster attributes for each identified cluster. Count. Okay, yeah. Okay. So rows, columns, same thing. Now we have a visited. In the what the fuck is this? False for all in range of columns or whatever in range of rows. Then we have the garden map and we have a cluster ID. Our directions are defined. We do the same loop. If not visited. What the fuck does this line do? If not visited, then our current block equals this. Our cluster ID plus one. We we make a queue, we append our value, we mark visited at that value as true, we set the count to 0 and different size to 0. While our queue, x and y is equal to q dot pop left. So our I and j and our count plus 1. For each direction, check the neighbors and our bounds checking. Neighbor block is equal to the next neighbor. If that is equal, and then this is the exact same logic. Else, if not visited, this, and then append that. Else, out of bounds counts as a different side. So we keep doing this until there's nothing left in our queue. Meaning, right? Yeah, until we don't have any more values that we've put into our queue. And so then after we're done, we store all this information into our garden map at this ID, and then we return garden map. Wow, that's disgusting. That's actually fucking disgusting. But instead of identify clusters, I just want this to be part one, and then it's passing through garden, which it wants it to be read garden file garden is this blah 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 blah. So what I'm gonna do actually real quick is take this, yank it, redo, and oh, redo, and then paste there. Pop up. I need a print. Also, I don't really care about a return. I just want to print. Is it garden I want to print? No, it's print the garden map. But line for line. So for line in garden map, print line. Is that how you do it with a dictionary? Um, not exactly what I wanted. Um, well here, nope, sorry. Let's go back to this. So at the value 1, we have our block R, count 12. Block 2 count is 4, 8. 14, 28. Okay, so it's reading correctly. So now what I want to do is I want to loop through this dictionary. I need to go use the bathroom real quick. Ah, I'm back. So looping through a dictionary. Um, how do you do this? Display. For cluster ID and info in here. Block equals info block count. Different sides equals info at different sides. Print all that. Okay. Zoop. Give me all that. Bop, 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 bop. Print me that pretty picture. Indentation level. Ay, caramba. What do you mean it doesn't match indentation? Wait, what doesn't match indentation? Garden maps items. Whoa, undo. Here, let's just. Yeah, beautiful. Make sure these all look good. 1, 4, 13, 18, 14, 22, 5, 12, 3. Yep. And so now I just want to take those two numbers. Um, I want to take those two numbers and I want to multiply them. So I want to say, I mean, I can just do it in here, right? For this, and this, I want, well, actually, different sides equals info, different sides. Oh, no, no, no. Results equals block int block times int count. And then total result plus equals result. Total results equals 0. And then print total, final total price. Total results. You got me. Invalid for int space, whatever. Ooh. What is this print off again? Oh, this is count different sides. Never mind. This is like 12. Yeah, count and then different sides. So sorry. This is int count times int different sides. 1930. Cheerio. Wow, amazing. Not like I mean, my approach was flawless, but like, I shouldn't say that. My approach wasn't flawless. because it missed out on the fact that you had to be in clusters, and then I didn't know how to handle clusters. So that was definitely my worst part one, easily. But time restraint. I'm sure I would have figured out something, maybe not that, um, where you do a depth first search on a value, which is really cool. Part two, I don't have time for part two, unfortunately. So we'll do this another day because I need to get working on this. So sorry. Okay, so first thing is first. I wanted to just look over um the solutions for the midterms. Just go through the ones that are important. Translations. Here, I can scroll in. Wow, flashbang. Actually, how bright is that? It's really bright. Okay. Rhonda ate Blaze's food in the morning, and if she did not also eat her own food in the morning, then she did not eat Blaze's food in the morning. So, A is denoting what? A means that dog X ate the designated meal for dog Y at a time. So, this is saying that Rhonda ate Blaze's food in the morning and did not and Rhonda did not eat her own food, Rhonda's food in the morning. If this happens, then this implies that she did not eat Blaze's food in the morning. So if both of these happen, right? Rhonda ate Blaze's food in the morning. And if she did not also eat her own food in the morning, then she did not eat Blaze's food in the morning. Meaning these either have to be true exclusively or it implies that this is true. I'm gonna check that DM real quick. I'm back. Uh, um, okay. Statement two is turning this into English. So this is saying that Rhonda ate Rhonda's food in the afternoon. If Rhonda ate her food in the afternoon, it implies that Rhonda ate Blaze's food in the morning and did not eat her own food. If Rhonda ate her own food in the afternoon, sorry, then Rhonda ate Blaze's food in the morning but did not eat her own food in the morning. Yeah, pretty easy. Universal quantifiers. So for all, wow, 77% got wrong. All right, let's see. Sorry. At each time, each dog's meal is eaten by exactly one dog. Okay, so for all T, Y, and X, wait, no. For all T and Y, so for all times, for all Y's, there exists an X. And all Z. So for all T, Y, and Z, there exists an X where some at each time, right? So this is representing each time. Um, some dog's meal was eaten by exactly one other dog, right? So it's saying Z is just saying that uh, 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 for all like dogs, because this is at each time each dog's meal was eaten by exactly one dog, meaning that these are two of any dogs, right? This one ate this dog's at any time, but then if this happened, then Z has to be equal to exactly one dog. This one's a little confused. I mean, this one makes it so like this is like okay for all dogs, but it has to be exactly one dog. So, the most common error is need for all quantifier on a dog. The four quantifiers in my solution above are all necessary. The exponential quantifier has to come in the right place. There are many other ways to write this. Some by using the fact that there are only two dogs in the set and using Boolean operators. Perhaps the shorter solution is for all T in all M. Uh, B, meaning for any time and any meal, Rhonda, Blaze or Rhonda ate it, but not both. Interesting. Interesting. Um, Blaze ate her own food at mealtime, if and only if it was the evening. Oh, uh, for all time, there just exists, not a time, but for all times, Blaze ate Blaze food at that time, but that time is the evening. So Blaze ate her food in Blaze ate her own food at a mealtime, if and only if it was the evening. Weird. Meaning that your version does not say both Blaze ate it and didn't eat it at other times. Okay. Every meal Rhonda ate at least one meal. There exists a time, and there exists a dog where Rhonda ate that dog's food. Okay. Okay, so predicates and proof. Using statements, I approve value of each of the three propositions. So truth table. Fun, isn't it? So, so prove these three. So what did they do? They did PQR, which are these three statements. They had P. I guess I don't get this one. Using only both questions 2 and 3 use definition predicates from the statements above. Use only statements 1 and 2 to prove. So what? I'm pretty sure there's a supplemental sheet at the end. Interesting. Yeah, this stuff I didn't really understand on the exam either. Binary relations on set, the relation. Oh, if M and N. If M and N are relatively prime positives, X mod A, mod M, and X mod N are two congruences. The naturals use the extension algorithm. So you take this. Why 10? Oh, you just go like down. The fuck am I looking at? Okay. And then true or false. If A is a finite set in R's relation from A to A and is an injection, a one-to-one function, then R is a bijection. True. Functions with finite domain and codomain of the same size are one-to-one, and if only and if they are onto. And this is stating that it's an onto function. Okay. If R is a reflexive and transitive relation from A to A, meaning it goes back onto itself. What's transitive again? I know it's in my notes. Transitive is, oh yeah, if there exists a path to a node, like two ways, then there'll exist one directly. And R is not anti-symmetric. Symmetric meaning goes both in this. Then R must be symmetric. So if we have R, right, and it's reflexive and it's transitive from A to A, and R is not anti-symmetric. If it's transitive and reflexive, I don't think it has to be I don't think it has to be symmetric, right? Because it can go onto itself and then it can go right here, but it doesn't have to go back. Yeah. Okay. Okay. Cool. Let's move on to that second midterm. After this one, I'm gonna stop the recording. Okay. Induction. Yeah. For positive naturals n, let's S then be this. Formally that. Okay, same thing. Examples, whatever. So first we want to write our predicate, which our predicate is just going to be this again, which is just n. And then they fucking like, actually, no, sorry. Proof by induction, all naturals, blah, blah, blah. And then you just restate it. Is defined n is greater than or equal to 1. Base cases, we already are given this base case. Now here is where I always get so confused, which is actually the inductive step. So the inductive step restates this, right? It restates this, and it's like, okay. So by the definition of summation, for some reason we can add 1 onto both of these. Sure. Well, I guess they're saying if it's n plus 1, then you can just like say like these are plus 1, right? Sure. By inductive hypothesis now, we can randomly just fucking split these like a fucking, I don't even know. And all of a sudden, bam, bam. Yeah, I don't get it. Marking notes. Don't care about this. I remember he had so many notes on that. Proof by induction, again. Relist. Prove base. Choose the root connected by inductive hypothesis. by the definition of depth. See, this one, either you're just plugging in like a max. I don't get this either. And he shows 3 proofs for that. Get me to the oh yeah, expression trees. Write a prefix. Okay. Are you really convinced of the other prefix? Okay. Search algorithm. So this was the one I went over that I pretty much just understand now. The only thing I don't understand is this one. Uniform. So carry uniform search. Okay, solution. We begin with this, which is 0. Oh, I'd like this to be. Actually, I think. Scroll, 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 scroll. Down one? Yeah. Okay. 0, Q. Then we take BE and put on this, which is 5. And this was the 7. And this, which is 8. So all the neighbors, because this isn't directed. Now we take off BAM. Put on no new nodes. We take this off, BAM, and we put Searsport. Eh. Oh, because it does this. It's 7, and then, so now we're at 20 at Searsport. I see. So we take off S8 and we put BU at 22. Oh, yeah, 22. Ugh. We take BU 22 off and put BH 38 instant on. We take this off and put that on. We take off. Since it's a goal node, we stop and conclude. Okay. Oh, so the other one, the uniform search, only looks at distances. Okay. Only looks at path distances, not heuristic value. Right? And then A star is 11. Put on this with 9, this with this, all neighbors we put on. We take off this. Ah, the rest of the would be a better history, a better line. Cool. I think the two things I need to really make strong attempts at this afternoon is um induction and DFS and all that stuff. So I think DFS is going to be a real highlight of this. Call me crazy. I think I'm just going to just do a little more induction, working on a lot. I think I'm really going to focus on these things that I have a good idea of. So like the translations, the searches, the graphs, and then multiple choice and stuff like that. And the induction stuff, I'm going to follow the correct format and I'll try them. But I think I'm way too. I can't learn this in 8 hours. Nope. So Uh, D is a directed graph with three nodes and no self loops. If D has at least five directed edges, it is strongly connected. But if it has only four, it may fail to be strongly connected. False. True. If five of the possible six edges are there, the six can be replaced by a two-step path. If four edges were fail. Yeah, that's what I meant. Sorry. Consider tiling rectangular L-shaped tiles. It is not the case that this can be done, if and only if. Okay, I'm going to call it here. Sorry for so finished Evernote Code Part 1 with a lot of help on some logic, time restraint. Um, Still need to do Part 2, which we'll do sometime this week. And then did this mainly took away from translations. Okay. Um, yeah. Sorry about the short one today. Just a little over an hour, but it is exam day, and I do need to work on this exam. I'll let you know how it went tomorrow. Like I said, most of these exams, from what I've seen, the final exams are these translations for the first question, and then two inductions, maybe even three inductions, and then it is a search, and then it is DFS and NFS. Um, and then 20, 20, 10 multiple true or false questions. So ideally, I do pretty okay on the true and false. Ideally, I do good on DFS and NFS with enough practice this afternoon. The searches should go pretty well. The translations should go pretty well. It's literally just this induction stuff that, is probably where the most of the points are going to come off. Um, so, but we'll see. I mean, I'll give it my best attempts as always. So yeah, I'll let you know how all that goes tomorrow after I'm done with it. But yeah, but after today, I only have 4 more days of like stuff I need to do. Um, in terms of my last class, and then after that, after Monday, like I said, the last like 2 days, um, it's winter break, and we should have a great winter break. I mean, I have two big projects I want to work on, and a lot of data structures to work on and sharpen and refine and learn. So I'm looking forward to it a lot. I move out on the first. I said in a previous video, but and then I'm off that whole month. So yeah. So looking forward to that. So gonna focus on exam rest of today. Next few days, I'll be able to. I'll definitely have the time the next few days to do like actual full like Avid of code, both parts, and then next week we'll start some projects. So yeah. I will see you tomorrow. Bye.